So, next up, we have Rohan from Telos AI. Up until recently, Rohan was actually the head of agent development at Citadel Securities. He led the development of their internal agent harness and spent a lot of time thinking about how to deploy LLMs safely and effectively in financial markets. Because as you kind of maybe imagine, you don't necessarily want your LLMs to go trading on the market without making sure that it's not going to do the wrong thing. More recently, Rohan actually started working at a company that he just recently founded called Telos, where he is working on building out simulated environments for coding agents. In both settings, Rohan has tackled the same basic question, which is, how do you trust your agent? Which is probably a pretty important thing in general if you're about to make a trade worth millions of dollars. Here's Rohan to tell us the answer.
Awesome. Well, thanks Amol for the intro, and I'm so excited to be presenting here in front of you all. So a big shout out to Agentics and Modal for making this happen. So yeah, as Bo mentioned, I worked at Citadel Securities on their coding agents, other kinds of agents, and definitely in the camp of people spending way too much time thinking about this space and problems. And I'm excited today to present to you all about scaling coding agent autonomy without sacrificing quality of outputs. Awesome. Okay, so maybe taking a step back in 2025, well, what a year, right? Vibe coding. Where does the year in 2025 alongside slop and glazing, apparently? There was extreme change in all of our lives in 2025 as developers. Starting with early 2025, where the models were only good enough to do tasks that could take a few seconds to a few minutes for humans. Reaching on to mid-2025, when we really started vibe coding with Sonnet 3.5, Gemini model, so on and so forth, reaching all the way to the end of 2025, where models got really, really good and started to be able to do tasks with Opus 4.5 that could take multiple hours. Where does that leave us? And where does that leave us as developers? Well, I think there's a fork in the road in the way we're using these tools. So on the left side, there's this synchronous paradigm. Lights on, reading the code, checking for slop, you're in. And a lot of developers are using this and having a lot of success with this. On the right side is the emerging paradigm of doing more asynchronous coding, where you're handing off your task via Slack to a background agent. You're using tools like Cognition or any of these other background agent tools to just give your agent more and more autonomy without reviewing its output. Now, while I actually think this isn't a continuous spectrum, here's a great graph by Swix on Twitter. Not sure if any of you follow, but there's two ends that really matter. There's the left side, where you're doing your best work. You're focused on the problem, you're in the loop, you're moving really quickly, you're making a lot of progress. And then there's the right side, where you're running a whole bunch of tasks in parallel, it's taking a lot of time, and this is kind of what we'll be focusing on. And the middle is interesting, right? The middle is not fun enough to sit there and wait. You know, maybe you're pulling out TikTok or Instagram and scrolling, or you're trying to context switch but unsuccessfully because your agent is almost done. I'm actually more interested in the right side here. And circle that in red because we're going to focus on that. Everyone knows how to vibe code and kind of check quickly. But what about leaving your agent alone for hours and hours on end? Can you really do that, right? And there's a few problems with this. I mean, you start off, and there's context fraud, and there's some excellent research on this, but essentially, for those of you who aren't familiar with context fraud, your agent is becoming really, really dumb as soon as you cross 50,000 tokens in context window, 200,000 tokens in context window. The context window is unfortunately a lie, right? So your models are getting worse and worse, and the models haven't quite gotten better at this problem. At the same time, there's issues with sycophancy and self-conditioning, where the model tends to believe that the work that's done is correct. And person over there with a shirt, you're absolutely right. One of the most dangerous strings they can't get coding. At the same time, you're encouraged to write rules for how you should operate in your code base with skills, with agents.md, but there's just no guarantee that your coding agent is going to follow these rules. And finally, this is really, this is going to hit close to home for those of us who've cared about the quality of our code. If the quality is really bad. And agents just love piling on complexity and tech debt and just eroding our code base. Is this a dead end? Can we solve this problem at all? We're thinking about. Okay, well, before we talk about solutions to this problem, can we even measure slop? And this is one of my favorite benchmarks of this year, just released, maybe a month and a half ago, slop code bench, right? This is amazing. This is exactly what we should be measuring, guys. And what you look at, and we'll go into how this benchmark works in a second, but as predicted, the best models in the world are getting maybe 20 to 30% on this benchmark. Okay, so how does this work and why is it relevant, right? And I think this is great because you're starting, and these benchmarks are measuring purely black box implementation of specifications as one part of it. The second part of it is they've got checkpoints. And real world coding is iterative, right? And if you want to look at why the models are bad at some of the tasks you ask them to do, maybe you should ask what they're trained on. And they're increasingly trained on one-shot coding tasks. So it's no surprise that when you're doing iterative coding, you add on a whole bunch of complexity. So I won't go into too much detail on how exactly this benchmark measures slop. That's a whole conversation and a whole conference talk in and of itself. But believe me that it does a pretty good job, and it at least measures that frontier models are not. Okay, awesome. So let's talk about a solution. And this is a solution that I've been experimenting with over the last few months. It's deceptively simple, and all I'm saying is pair your agents, right? And you have a generator, which is the agent that's writing the code, proposing diffs, and an evaluator agent that's reviewing this code, and they're kind of ping-ponging between each other until the evaluator says that you're done, right? And the input to this loop is a spec or a plan that you've come up with after iterating, plus maybe the skills that you want in your code base. This is simple. What are some real results? Let's look at a quick demo on on some examples here. And this is an example derived from applying this loop on a front-end design task, showing you how this loop optimized using the skill some front-end code. Okay, so as you can see, there is the model's first instance at creating a web page. And after 10 iterations, you get a much, much better UI by applying this loop. This is one that I think is more interesting to me. Here's a website, clearly vibe coded. Now what happens after you spend 10 iterations of feedback? Well, you get something that, dare I say, is close to tasteful. This is a museum website. You're jumping in, you're trailing things. Nice work, Claude. I didn't know you could do that. Okay, so here's where I come in, and here's what I've been working on. I'm working on Telos, which is an open source spec-driven agent runtime, which runs the generator evaluator loop on specs that you write, plans that you produce, generally long horizon declarative goals, using coding agents that you already pay for. So I'm sure many of you have maybe max plans or pro plans that are underutilized. This is a great way to hit 100% if you're looking to max that out. Okay, so I have real results. I'm not just coming up with this let's have multiple agents play with each other. On Slop Code Bench, running on a subset of selected problems, what you'll see is a real trade-off between what your priorities are as a developer. And of course, there's functional requirements, which you can measure as precision and recall. I'm using precision here as a way to see how good of a job the agent did in terms of correctness, recall in terms of how much of the spec or the plan it actually implemented, and verbosity, erosion as key code quality and slop metrics. That's also used by the Slop Code Bench. And through my analysis, the generator evaluator loop produces far, far less slop in terms of verbosity, erosion, does better on recall and coverage of your spec, does a little bit better on precision, but there's really no massive gains there. And of course, you're paying for this in runtime and costs. You're spending more money, you're spending more time to get a better quality result. And as we enter the age where models are good enough to run for a while, maybe there's tasks where this makes sense. And maybe there's tasks where it makes sense to sit there, spend a bunch of time writing a really long prompt. Yes, Paul, I like writing long prompts as well. And just go for a walk, right? See what happens. And internal to my time at Citadel Securities, the biggest result that we had with this method was leaving an agent unattended for 4 days to write coverage across a 1 million lines of code base. And the best part here, the result that I'm most happy about was we actually merged this PR because it wasn't filled with slop. And there was a PR with over 100,000 lines of tests, and we got to merge it on only a few iterations, and that was awesome. At the same time, this pattern is useful for other open-ended, long-running tasks, migrations, code migrations, data migrations, performance optimization, and end-to-end spec the code generation when you already have a well-defined spec. I also want to underscore how this technique can help you ensure your coding agents are actually conforming to your skills and your agent MD and your code stuff. So if you're like me and you're really, really pedantic about not having too many class methods or what have you, you can make sure that Claude's never doing that by spending some more tests on the compute. Okay, awesome. So maybe taking a step back, wanted to just share something I came across that I really, really liked. So here's OneWords, and OneWords is a software library with no code. You just see spec.md in the library and a few tests. And this is pretty awesome. This is by Drew, an open source, and just really contemplating the idea of pure spec-driven development. And we're still early, and of course the agents are still producing a lot of slop. But maybe through techniques like this, something like pure spec-driven development will actually be possible. Wanted to leave you all on that note. On that note, thank you very much. The open source code base is here if you want to try it out on using your local free Claude Max tokens. And I'm also happy to chat about this on platforms here. Cool, thank you. Any questions?
I'm actually going to steal the first question, if that's okay. So I'm sure you've heard a lot about TDD, test-driven development. How do you see this approach as building on top of or differing from TDD? Is this something that people should do in addition to any TDD that they're already doing, or is it something that you think of as like a totally different axis? Like, talk to me a little bit about that.
Yeah, I think TDD is a great comparison to what's happening here. I think I personally view TDD as this more of like a philosophical process of sitting down and deciding what is a contract of my program, and what is sort of, in a more declarative sense, what do I want out of this? And sort of saying, here's this feature, implement this in an imperative way. And this method of programming, maybe spec-driven development, if you could call it, is really about encoding your contract in verifiable words that this verifier can go hammer against and not let the generator through in passing. So 100% related, 100% agree. There's a lot of overlap there and a lot of value.
Slightly different question. Did you guys review that 100,000 line code, like that PR that you guys merged over 4 days? Like, how did that work?
Yeah, that's a great question. So we did a lot of review for the sections of code that touch production code bases. But when you're writing a lot of tests, sometimes the tests are it's fine because there's coverage that's added. So when we have numerical signal on coverage, we didn't have to review as much of the code. When there were instances where tests were coupled with bug fixes, of course we had to review the code. But yeah, you just can't review that much code. So what do? Well, maybe you verify against slop, something like that.
Hi, do you see an advantage of using different models for the reviewer and the generator?
This is a great question. So some of the inspiration for this work actually came out of a 2024 paper by OpenAI, where they showed that you can pair a smart language model with a weak language model as a verifier to produce really good results. And a lot of the work that I'm doing here is pairing a smart model like a Codex or a Claude with a cheap open source model to perform verification. There's an inherent asymmetry between the task of generation and verification, which lets you get away with using a cheaper and smaller model. In general, with paradigms like this that leverage more inference time, test time compute, I'm excited by the possibility of using 10x cheaper and 10x faster models to get better results. In my own testing, I've been able to see that using a model like Kimi K2.5 over 10 to 15 rounds produces better results than a one-shot result from Claude. And guess what? Kimi K2.5, 10 to 15 rounds is still cheaper than Claude. So is that telling you something about Anthropic or not? I don't know. I'm not going to make names here.
Cool. One question that I have regarding this, we have been hearing for a couple of years now, or maybe it was last year, I don't know, regarding route loops in order to keep the engines running longer, in order to accomplish goals. There is a cloud code plugin for that. Codex recently launched like a /goals feature just to keep the engines running longer. I wonder how Telos compares to that.
This is a great question. I think the Ralph loop, I think, is the maybe the younger cousin of this kind of approach, right? I think the Ralph loop is really centered around repeating on the same task. What we're seeing is that actually spending more compute on adversarial pressure allows you to scale the Ralph loop without devolving your code base into an absolute sort of slop fest, right? And this is this is the common criticism of Ralph loop, is that you run it for more than 20 hours, and now you suddenly have 100 markdown files committed in your repository, right? So I think this is just a natural evolution of that paradigm.
All right.
Awesome. Well, thanks everyone.